Here to present you with Rover X. Unique and innovative, the Mars Rover-inspired educational toy aims to provide high school students with a fun and interactive learning experience. This project was created to address the problem of high school students' lack of engagement with STEM subjects. It's common knowledge that these subjects are essential for the development of future technology, engineering, and science leaders. The motivation behind the project is to create an educational toy based on the Mars Rover that can move autonomously through a predefined pattern. Different levels of difficulty will be associated with the toy, and students can purchase different add-ons based on the topics or difficulties they wish to practice. The base design of the toy will be able to automatically move following a predetermined pattern and the following levels of difficulty associated with the toy. Students will be able to control the rover manually through an app. Level 1. This level teaches students the fundamental of app development and programming. Students at Level 2 will be able to construct a solar charging station for the Mars rover. This level teaches students the fundamental of solar energy and power systems. Finally, in Level 3, the students will be able to identify different colors of a tennis ball, introducing basic concepts in computer vision and image processing. By the end of the project, the goal is to achieve several objectives. First, the project aims to create an educational toy that is fun, interactive, and engaging for high school students. Second, the project aims to inspire and motivate students to pursue careers in STEM fields. And finally, the project aims to introduce students to the basics of subjects that are not covered in school.
We are a team of undergraduate electrical and electronic engineering students who have noticed there's a gap in the market. Before coming to uni, we all felt like we had little to no exposure with hands-on projects involving electronics, due to a lack of opportunities presented to us at school. As a result, there was a big jump from school to uni, with a lot of us not having experience or knowing what to expect. We hope that this product can be used in various ways. A key purpose is to be used as an enrichment tool, both in and outside of school. Furthermore, the different levels can be used to target children of different ages and to allow them to gradually work their way up the levels as they become more confident and gradually expand their skill set. It will also allow them to target certain skills which can then be used to build on things that they learned in the classroom. We also believe it's more accessible than products in the market which have a similar idea, such as Lego Mindstorms, as we were planning to price it lower. Furthermore, unlike Mindstones, it allows for the toy to be tailored for use by a certain age or to target specific skills, rather than paying a lot in one go to have access to a lot of components. This can often be overwhelming to kids, and as a result, we have taken a more incremental approach. We hope to launch this product in the market by November 2023. This would allow us to target schools ahead of the new year. And furthermore, it would provide an opportunity for individuals to buy the product as a gift during the build-up to Christmas.
Investing in our startup is a smart move because the educational robot market is growing rapidly. According to the Educational Robot Global Market Report 2023, the market size is expected to be $1.72 billion in 2023, with a compound annual growth rate of 18.8%. This market is projected to reach $3.37 billion by 2027. In the UK alone, the market for educational robot toys has already reached over £500 million. Our startup is on a mission to capture a share of the educational robot toy market by targeting a specific demographic that's been largely overlooked by our competitors. While most of our competitors, such as Lego or Sphero, focus on children aged 5 to 12, there's still a huge market gap for secondary school students aged 12 to 18. That's where our Mars Rover education toy comes in. It's uniquely positioned to provide high school students with an exciting and hands-on way to learn about different engineering topics, coding, and space exploration. By investing in our startup, you'll be able to capitalize on this growing market and help us inspire and educate the next generation of explorers and engineers. Don't miss out on this opportunity to be a part of something special. Invest in our startup today. Our startup is headquartered in London, and our starting market will be in the UK. We will expand to Spain in 2024, China, where we manufacture, in 2025, and the US in 2026. Our revenue will primarily come from the sales of the base rover design kit and the different add-on projects. The product can be sold through an online store which can be set up using e-commerce platforms such as Shopify or Amazon. Partnerships will be established with secondary schools to provide the Mars Rover education toy as part of their curriculum or extracurricular activities. Revenue can be generated through bulk sales to schools or through licensing fees for the use of the product in the classroom. SWOT analysis is a simple, powerful tool that allows us to identify the strengths, weaknesses, opportunities, and threats of our project. This analysis helps us to capitalize on our strengths while identifying and mitigating our weaknesses. Our impressive strengths include our educational value. The Mars Rover toy can teach students about engineering, robotics, and other STEM subjects. The toy is fun and engaging, which can help to motivate them to learn. It is also modular, allowing children to experiment with different add-ons. The weaknesses we have and are aiming to mitigate are our price. We understand that our product may be considered expensive by some customers, which limits its accessibility to some families. Our visibility. Our startup brand is not yet established in the toy industry. There are many opportunities we aim to benefit from. The toy can be marketed as a tie-in to educational programs. The success of the toy could lead to the development of additional space-themed educational toys, which could broaden the appeal of the brand. Partnering with large organizations such as NASA or SpaceX could help us to increase the credibility of the toy and attract more customers. Last, we have some threats. We have some competition that are somewhat similar educational toys, and advances in technology could make the Mars rover toy less impressive.
We have a clear roadmap and budget for each stage of the project. The 3-month design stage will cost around £300,000, providing a solid foundation for the Mars rover education toy. And the 3-month prototype stage will cost around $480,000 and cover materials, manufacturing, and labor for a fully functional product ready to be tested and brought into the market. In the design stage, we have broken down the cost into 4 main categories: personnel costs, material and supplies, equipment costs, and legal and administrative costs. Personnel costs will cover the majority of the design stage budget, accounting for 81%. This investment will allow us to hire 3 experienced engineers who will support and design our product. By bringing in experts into this field, we'll be able to ensure that the Mars rover education toy is designed to the highest standard, both in terms of functionality and educational value. As we move towards the prototype stage for our Mars rover education toy, we have expanded our cost breakdown to include the critical expenses such as testing and validation costs to ensure reliability, documentation costs for clear instructions, and manufacturing costs for productions. With these expenses covered, we'll be one step closer to providing high school students with an exciting and hand-on way to learn about robotics, coding, and space exploration through our Mars rover education toy. In the development and testing course, we have carefully considered all the necessary expenses, which include fees for prototype design and prototype testing and validation. We are also planning to hire interns and a specialty testing agency to assist with the testing process, which will help us keep costs down without compromising on quality. And to calculate the cost per product, we have taken into account various factors, including material costs, production costs, administrative costs, and distribution costs. For example, the administrative costs cover overhead expenses such as office rents, insurance, and salaries for admin staff. Finally, distribution costs include expenses related to shipping and handling, as well as marketing and sales costs. Hence, we estimate that the total cost per kit is approximately 11.58 on average. This cost includes all the expenses necessary to deliver a high-quality product to our customers, while still maintaining a reasonable profit margin for our company. After carefully calculating our cost per kit, we estimate that we can sell each Mars rover education toy for approximately £41.75, which results in an estimating profit of £30.17 per product sold. These profit margins taken into account of all our estimated costs, as well as a reasonable markup to ensure that our business remains profitable and sustainable over the long term.
Channels to identify and address any potential design or manufacturing issues as soon as possible. We also acknowledge that the product may not meet market demands, but we will conduct thorough market research to identify the unique needs and preferences of our target audience. We will develop an effective quality control issues may result in a product that doesn't meet the quality standards for school use. We will mitigate these by implementing quality control measures, conduct regular inspections to meet all critical product specifications, and test the product thoroughly to ensure that it meets these standards. We will make necessary design or manufacturing changes based on the inspection and testing results. Issues in the supply chain or shortages of resources may lead to delays in manufacturing too. We will develop a contingency plan for resource allocation and collaborate closely with suppliers to ensure timely supply as well as having backups. We have identified and addressed potential resources early. Delays in manufacturing or testing may impact the overall project timeline and delay the launch of the product. We will develop a detailed project schedule that accounts for potential delays and includes contingency plans. Continuously monitor progress against the schedule and adjust the schedule and contingency plans as necessary. We also acknowledge that there may be unforeseen design or manufacturing issues that may cause delays in the schedule. We will develop a comprehensive risk marketing plan, including targeted outreach, promotions, and ads. We will continue to monitor market feedback and adjust as necessary.
Before commencing with the project, we will provide a comprehensive deliverable plan outlining all our milestones and deliverables throughout the project cycle. We will start with the initial working prototype and mocking up preliminary specifications, drawing and sketches, including materials, dimensions, and production methods. This will then lead to our complete project plan, which will include a breakdown of what must be achieved and by when. Our technical specs and virtual model will help to ensure that the investors have a sound understanding of the product. Thorough testing is essential, as it is a product that's going to be placed on the market, and we need to ensure that there's no electrical hazards or general safety hazards. Extra care must be taken as it is aimed at children, and finally, validation tests will help ensure the product meets its purpose and the stakeholders' needs. Here is a breakdown of the costs that we incur during the development process. Salaries will need to be paid to lead members of the startup and hired contractors, such as the web developers, and to employees trained to maintain the machinery to help with the general upkeep and ensure everything is running smoothly, alongside to manufacturers that are hired to help produce our product. Buildings will need to be hired, such as office space and warehouse space, and materials and equipment include raw materials needed for production, the packaging costs, machinery and equipment hire in factories, and the shipping costs from the factory to us, as the customer will be paying for the cost between us and them. Energy and utilities will include those using the office space and by the machinery in the manufacturing process, and alongside transportation costs. Marketing and advertising can be split into two subsections, including costs associated with content creation and with uploading advertisements. So our startup currently consists of 5 members. They will each be having a key role as follows. So our CEO is Kelvin, and he is responsible for our business's overall direction and makes the major corporate decisions and manages our overall operations and resources. He's the main point of communication between the company and externals. Our COO is me, Tanya, and I'm in charge of day-to-day operations and processes in place towards the business's overall vision. The CFO is Gonzalo, and he is responsible for the financial health of the business. He analyzes and reviews financial data, reports on financial performance, and carries out the budgeting. Our CMO is Patricia, and she's responsible for planning, development, and implementation of our marketing strategy. This includes the market research, pricing, advertising, and any communications involved. Our CTO is Kristina, and she helps lead the tech and engineering department, and she's responsible for developing the tech processes.
Following hierarchy for the design stage. Kelvin is our CEO, who has strong leadership skills, vision, and the ability to make tough decisions in the rapidly changing business environment. He was a co-founder of a company and managed to get funding from various angel investors and successfully launched his startup, so we decided that Kelvin is the right person to lead our team. Then we have the rest of our management board, with Tanya being Chief Operation Officer. Tanya understands the company's operations and can effectively manage the organization's day-to-day functions. She has strategic thinking and great problem-solving skills. She developed all of these skills while taking a position of ESOC president. She manages the administrative team, which consists of office manager and executive assistant. Gonzalo is our Chief Financial Officer, who can effectively manage the financial affairs of our company and provide strategic financial guidance to the executive team. Gonzalo has very strong analytical skills, which helps him to use data and financial information to make informed decisions and identify opportunities for growth and improvement. Additionally, Gonzalo got the highest grade for accounting, so he is the best candidate for this role. Patricia is our Chief Marketing Officer because she has a strong combination of strategic, analytical, creative, and interpersonal skills to lead a company's marketing efforts to drive growth. She has very good collaboration skills and loves working with people. Patricia manages marketing team and the sales team, which consists of digital marketing director and sales manager. And I am the Chief Technical Officer because I have deep technical understanding of the project and pay great attention to detail. I took leading roles in multiple engineering projects where I developed various technical skills that can be easily transferred and applied in any engineering projects. I manage the engineering team, which consists of lead engineer, senior engineer, and junior engineer. For the prototyping stage, we would employ more people in the engineering team, as well as marketing and sales team, in order to work more efficiently and start selling faster.
We will also be hiring externals, such as a web developer, to help us build and maintain a web app, which can then be used alongside our product. They will also help with our website, where our product will be available to purchase, alongside access to specifications. Warehouse workers will also be hired to oversee production and handle the machinery, whilst lawyers will also ensure that our patents and legal logistics are all sorted out and are in order. So here is the Gantt chart showing our proposed timeline for the product's development and launch over the upcoming year.
We did not have a very strong emphasis on documentation, worked rather on delivering the product as soon as possible and iteratively made adjustments to our product as we went along. So our project model was more like agile, with regular Scrum meetings and intensive sprints, where Kelvin was our Scrum Master and we collaborated to improve our project idea. As for communication of changes, we decided to put our suggestions or concerns on the table straight away in the beginning of our Scrum meetings, and then we collaboratively made a decision.
Our break-even analysis shows that we need to sell around 40,000 kits to reach the break-even point, which translates to 1.88 million in revenue. This is a reasonable target considering the size of the market and the unique offering our product in the education robot toy space. With the cost per kit of £11.58 and an estimated profit of £30.17 per kit, we are confident in the potential of our business. Based on our financial projections, we anticipate achieving sustained net profits by 2026, with a project profits of 3 million by 2029. With a solid business plan and innovative products and a growing market, we believe that our company has the potential for substantial growth and long-term success. By investing in our business, you will not only by supporting a promising venture, but also stand to benefit from significant returns on your investment. Of course, our business model is not only focused on the profitability, but also on generating value for our investors. With a 20% internal rate of return and a 5-year payback period, investing to our company is a smart choice.
We are aiming to build a 670-gram robot with a similar size to a book or a diary. The main chassis is going to be built of aluminium due to its structural properties as well as the impact it creates to the environment. Our educational toy comes with a comprehensive set of educational materials including manuals, tutorials, and lesson plans to guide users throughout the project, as well as advising of safety hazards and correct use of the robot. Before releasing our Mars-inspired educational toy, we will conduct extensive user testing to ensure its safety, efficacy, and user-friendliness. We will seek the assistance of experts in the field of robotics to test the efficiency and validity of the robot design, ensuring that it functions properly and provides students with a beneficial learning opportunity. Finally, we will conduct user testing with high school students in order to obtain their feedback and ensure that the toy is both enjoyable and engaging. This testing will allow us to fine-tune the design of the toy and ensure that it meets the needs and expectations of our target demographic. The robot's bill of materials estimate the raw cost of the materials. Our base model production is 5,000 units, and the total spent is of £21,838, resulting in a cost per product of £3.97. We also have to take into account that these costs exclude the indirect costs like labor, manufacturing, or energy. On top of this, as shown in our add-ons bill of materials, we can see that as complexity increases, the kit price increases.
To help us achieve our mission of inspiring and educating the next generation of explorers and engineers, we are seeking a total of $1 million in funding to cover our expenses and fuel our growth. By investing in Rover X, you are not only investing in the future of education, but also the future of space exploration. Rover X, taking learning out of this world. Thank you.